Hello, happy people of the Pre-Calc world. This is Mr. Wilcox coming to you again from my kitchen table. Last week we were talking about limits where we could just do direct substitution, or before we could do substitution, we had to factor. Today we're going to be talking about limits with radicals. This will be the only video for this week because this week we're focusing on limits with radicals and limits to infinity. And we've talked about limits to infinity before, so you should have the note sheet that reminds you how to do limits to infinity. So today we're going to talk about limits with radicals. And before we can actually talk about what to do with limits with radicals, we have to remind ourselves what a conjugate is. So I'm going to pause here so you can write down these two statements in your notebook. All right, hopefully you pause the video and push play again. So a conjugate is just an expression formed by changing the sign between two binomials. So remember we used the conjugate before to prove trig identities, where we had if we had the cosine of something plus 1, we would multiply it by the cosine minus 1. So we're just changing the sign in a binomial. And the reason we do that is if you multiply conjugates, you get the difference of squares. Because if you box or FOIL two conjugates, the centers, you'll get a positive and a negative, so they will cancel out. So that is what we're going to use for conjugates in today. So here are the steps we're going to use and the first example we're going to do. I'm going to do that example on the next slide. So I'm going to again pause for a second so you can pause the video, write down the steps, and then we will continue from there. All right, so again, the only time we have to actually do any work is if direct substitution yields a denominator of 0. So if you plug in the number that this number that our limit is going to right here, and on the bottom you get 0, then you have to do some work with conjugates today. So after we multiply the top and bottom by the conjugate of the part that has the radical in it, then we're going to simplify. And then after we simplify, we should be able to do our substitution now so that there is no 0 on the bottom. Because remember, we can't divide by 0. You can't just say no limit right away if you get a 0. Remember, you might have to factor, or today we're going to multiply by the conjugate. So let's do this first example of the limit of, as x goes to 1, of the square root of x minus 1 over x minus 1. So if you notice, if we plug in our number that our limit's going to 1, if we plug that in the bottom, we'll get 1 minus 1, which is 0. So we do have to do some work in order to get that bottom to not be 0. So what we're going to do is we're going to multiply the top and the bottom by the conjugate of the part with the radical, and that would be our numerator. So the conjugate of the square root of x minus 1 is the square root of x plus 1. And we're going to multiply that on top and bottom. So on top, if I box or FOIL out the square root of x minus 1 times the square root of x plus 1, I'm going to get the square root of x times the square root of x, which is x. So we're going to have the limit as x goes to 1 of x. And then we'll have negative 1 square root of x plus 1 square root of x, which cancels out. And then we'll have negative 1 times positive 1, which is negative 1. And on the bottom, I'm going to leave my x minus 1 the same, and I'll have the square root of x plus 1. So what happens is, because I'm multiplying this x minus 1 times this conjugate, and I have an x minus 1 on top, the x minus 1's cancel out, leaving me the limit of, as x goes to 1, of 1 over the square root of x plus 1. And now all we have to do to figure out that limit is do direct substitution. So I'm going to get 1 over the square root of, and the number we always plug in is what our limit is going to. So we're going to plug in the 1. And the square root of 1 is 1. And 1 plus 1 is 2. So our limit is 1/2. So this function approaches the value of 1/2 as as x goes to 1. All right. So I'm just going to do a few more examples with you so that we get used to multiplying by the conjugate with radicals, and then you'll have time to work on your homework for the day. So our first example is the limit as x goes to 16 of the square root of negative 4, the square root of x minus 4, over x minus 16. So first thing we should always check out is if I plug in that 16, do I get a 0 on the bottom? Well, 16 minus 16 is 0. So yes, I do. So I can't just use direct substitution right away. I have to actually do some work. So the work that we're doing now is we're going to find the part with the radical, and we're going to multiply by that conjugate. So our numerator again has our radical. So the conjugate of the square root of x minus 4 is the square root of x plus 4. So I'm going to multiply by that on top and by that on bottom, because if I multiply by that on top and bottom, I'm only multiplying by the greatest number of all, remember, which is 1. So on top, if I take my square root of x times minus 4 times the square root of x plus 4, square root of x times square root of x is x. I'll have negative 4 square roots of x and positive 4 square roots of x, and those will cancel out. So then I have negative 4 times 4, which is 16. On the bottom, I'm going to keep my x minus 16 and my square root of x plus 4 separate. So again, my x minus 16 and my x, that's a 16, sorry. My x minus 16 and my x minus 16 cancel out, leaving me with just the limit of x goes to 16 of 1 over the square root of x plus 4. So what I'm going to do is I'm just going to plug that 16 in. So I'm going to get 1 over the square root of 16 plus 4. The square root of 16 is 4, so I'll get 1 over 4 plus 4. And 4 plus 4 is 8. So my fraction is simplified. So as my x goes to 16, this function is getting closer and closer and closer to 1/8. All right. So I just have 2 more examples for you, and then this video will be done. All right, so here's our second example. We have the square root of x plus 4 minus 4 over x minus 4, and we're trying to take the limit as x goes to 5. So the first thing we need to do is we need to check in if we plug in our number 5 here, do I get 0 on the bottom? And if I take 5 minus 4, I get 1. So here I don't have to actually multiply by the conjugate because I don't get a 0 on the bottom, so I can just use direct substitution. So in for x, I'm going to plug in that number that x is going to, which is 5. So I'm going to get the square root of 5 plus 4 minus 4 over 5 minus 4. So if I just simplify that, I'm going to get the square root of 9 on top minus 4. Well, for 5 minus 4 is 1. So I'll get 3 minus 4 over 1, which is negative 1 over 1, or negative 1. So again, don't be in such a hurry to do the factoring step or do the conjugation step. You may be working too hard if the number that we're plugging in does not actually get us a 0 on the bottom. And remember, the number we always plug in is whatever number our x is going to. So in this case, it was 5. So that's why I plugged in 5. And I didn't get a 0 for a denominator, so I could just plug it in and get a limit going to negative 1. All right, I have one last example for you, and I just wanted to do one example where the radical's in the denominator. So if we look at the limit as x approaches 9 of x minus 9 over the square root of x minus 3, again, check out our number on the bottom. We're going to plug in 9. If I take the square root of 9, I get 3, and 3 minus 3 is 0. So I do have to do some work before I can actually take this limit, because remember, we can't have a 0 on the bottom. So I'm going to multiply by the conjugate of the part with the radical, which is our bottom. So the conjugate of the square root of x minus 3 is the square root of x plus 3. Remember, I have to multiply it on top and bottom so that I'm really just multiplying by the greatest number ever, which is 1, which doesn't change anything. All right, so on top, I'm just going to leave my x minus 9 and my square root of x plus 3 as separate things. And on the bottom, I'm actually going to do that multiplication of the conjugates. So square root of x times the square root of x is x. In the middle, I would get a negative 3 square roots of x and a positive square roots of 3 of x. So those cancel out. And then I take negative 3 times positive 3, which is negative 9. So again, on top and bottom, I have an x minus 9 and an x minus 9. And because they're remultiplied, you can cancel them out. So I'm going to have the limit as x goes to 9 of the square root of x plus 3. And if I plug in my 9, this is square root of 9 plus 3, which gets me 3 plus 3, which is 6. All right, so that's how you find the limit by taking the conjugate of the part with a radical. Hopefully you're watching these videos, because if you are, you'll find out that today one of your problems in your packet has no limit. So one of your problems today should have an answer of no limit, because it does not work out very nicely. Again, you have to do this work in order to figure that out. So I hope you are happy, I hope you're healthy, and I hope you have a great day.